Today we will discuss about Routh stability criteria. Routh stability criteria, it is a technique to find the stability of the system, that is to know how many right hand side poles are present. In the control systems, we know that for a system, if there are right hand side poles, the system will be unstable. For example, if we take e power plus t, for which the control e power plus t. So for this, the transfer function is 1 by s minus 1 and the function is increasing function. So this is for a bounded input, there is an unbounded output, hence the system is unstable. So if we have the right hand side pole, the system will be unstable. So for directly, without solving the characteristic equation, we can find how many right hand side poles are there, thereby finding the stability of the system. So for stability, let the transfer function be g of s by 1 plus g of s into h of s. So the characteristic equation will be 1 plus g of s into h of s. For example, characteristic equation is s naught s power 4 plus a1 s3 plus a2 s square plus a3 s plus a4. This is a simple fourth order transfer characteristic equation. So for stability of the characteristic equation, there should not be any sign changes in the coefficient of the characteristic equation. So sign changes means a0, a1, a2, a3, a4 should be either positive, all should be positive, or all should be negative. That is the meaning of this statement. There should not be any missing coefficient in the characteristic equation. Missing coefficient in the sense a0, a1, a2, a3 and a4, all the coefficients should be present. None of the above coefficients should be equal to 0. If any of the coefficient is 0 or there are any sign changes in the characteristic equation, from seeing that we can tell that the system is not stable, but we cannot come to a conclusion whether it is marginally stable or unstable system. So the above two conditions are only necessary conditions, but from finding the RH tabulation, we can find both necessary and sufficient conditions also. So let us go further and see how can we tabulate a RH tabulation and what are the necessary conditions. So RH tabulation, let the characteristic equation be s naught s power 4 plus a1 s cube plus a3 s square plus a cube s plus a power 4. Then RH tabulation s power 4 an s power 4. So we should let now for RH tabulation, the simple method is draw a straight line vertically straight line. On the left hand side, write the highest coefficient. On the first write the highest coefficient s power 4. Now decreasing order, write the other s's in the decreasing order, s cube, s square, s power 1, s naught. Now on the right hand side, first write the coefficient of the highest order, a naught. Now alternatively we should write the coefficient, i.e. a naught, a2, a4, a naught, a2, a4. Next for s3, the second write the coefficient of the s3, a1. Now alternatively s1, a1, a3, a naught. Now the other rows we should find the other elements of the rows from the first two rows itself. Okay, for this can be found by a1 minus a1 into a2 minus a0 into a3 by a1. Okay, a1 into a4 minus 0 into a0 by a1. So a1 a0 cancel, then we can directly write this a4. Now let this big coefficient be a, so a into a3 minus a4 into a1 divided by a. That will come here. This will be equal to 0. A into 0 minus 0 by a is equal to 0, and directly this a4, that is this big coefficient, this into a4 minus 0 into a by this coefficient will be a4. So directly we can write a4. So the RH tabulation is like this: a0, a2, a4. a1 a3 a0, this a4 0, a into a3 minus a4 into a1 by a, this a4 will come here. So from this tabulation we can conclude that these are the necessary conditions for stability of the system. There should not be any sign change in the first column of the above RH tabulation, that is this a1 a0 capital A into a3 minus a1 a4 by a and a4 should all be positive or should all be negative. If there are any sign changes, i.e. positive, negative, positive or positive, negative, any sign change is present, then the system is not stable. If any sign change is present, then there are right hand side poles. So number of sign changes is equal to number of right half of the S-plane roots. For example, positive, positive, negative, positive, positive. It is the final conclusion. So there are two sign changes, i.e. positive to negative one sign change, from negative to positive two sign changes. So there are two right hand side poles. And one more example, if this is positive, 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 negative, so only one sign change, positive to negative, only one sign change is present, so only one right hand side pole. So this is the theory topic. In the next video we will see some important problems.